this question we previously discussed the same question for calculating the deflection. So here we also want to calculate the maximum width of cracking. So due to deflection the crack occurs. So in some questions they ask deflection and also what maximum width of crack. Okay, so in some question what they want to calculate the width of the crack separately. So here we want to calculate the width of the crack. So the same question we already discussed in deflection control. Okay, so first you want to write the given data. Okay, given data. So here we want to calculate the maximum width of crack. So this maximum width of crack equation is already given in Annex F IS 456. So this equation we want to by heart. Okay, no, sorry, don't want to by heart this equation. Okay, so this is WCR is the crack width. Okay, WCR is the width of the crack. So we want to calculate these parameters. Okay, ACR, epsilon m, then C minimum, H and X. Okay, sigma m is already also given in this question, but here epsilon not sigma, epsilon m is also given in this equation. Then we want to calculate the epsilon L value, that is the strain at the level level considered, calculated ignoring the stiffness of the concrete in tension. So that is the strain in the tension zone equation we want to by heart, and also ACR equation we want to by heart. Okay, so after writing the given data, then you want to write the main equation, that is the WCR equation. Then you want to draw this figure. Okay, you want to draw this figure. This is a rectangular beam with number of longitudinal bars. Okay, this is the elevational view or the sectional view is given. This is a sectional elevation view given in this question. So first you want to calculate the ACR. Okay, first you want to calculate the ACR. What is ACR? ACR is the distance from the point considered to the surface of the longitudinal bar. That is, if here the crack occurs. Okay, so this point, okay, this point to the longitudinal bar center, this is the crack occurring point. Okay, this is the crack occurring point. So ACR is the distance from this point to the nearest longitudinal bar. So we want to by heart an equation for calculating ACR, that is root of S divided by 2 the whole square plus C minimum. C minimum means the clear cover, that is the base of this bar to the this portion, that is C minimum, and S means the spacing between two bars, center to center spacing. If the center to center spacing is not given, you want to assume the value. So here spacing is not given in the question, so assume as the 60 mm. Okay, then you want to calculate C minimum. So we already have or take the clear effective cover as 50 mm. So if the C minimum is the base of the bar to this point, so this effective cover means center of this bar to the base point. Okay, so C minimum means 50 minus this half the diameter of the bar. Okay, that is 50 minus D by 2 gives C minimum. Okay, then substitute S by 2 C minimum to the equation and calculate ACR. Then we want to take the sum of the values for calculating epsilon L, that is the main equation is WCR. Okay, so for calculating WCR we need ACR epsilon M. ACR we already calculated by the equation root of S by 2 the whole square plus C minimum the whole square. Okay, then we want to calculate epsilon M. So epsilon M equation is epsilon M equal to epsilon L minus this one. So next our aim is to calculate epsilon L. So how to calculate epsilon L? For calculating epsilon L we want to by heart this equation. Okay, so the epsilon L equation is this. Okay, Fs. For calculating first Fs, another equation m into my divided by IR. Okay, this m is the modular ratio, this m is moment, y is this distance, and IR we already calculated in the deflection question. So we already calculated m modular ratio in the deflection question, so refer that. Okay, so m is 30. Then moment is given in the question as 140 into 10 raised to 6, and also the y equation is the r we already calculated in the deflection question, and IR we already calculated. Then substitute in this equation. Okay, then we get epsilon L value. Okay, we get the epsilon L value. Epsilon L value. Okay, then after getting epsilon L, substitute the values in this epsilon M. B is already given the question, H is the capital D, X is the, we already discussed in the deflection question, A is the H equal to A. We take here the question H equal to A. X is already calculated in the deflection question because both the questions are same. Okay, so refer that one. Then substitute all the values. So finally we get ACR epsilon M. Then substitute in the WCR equation. Okay, WCR equation, and we have one check that according to IS 456 clause, this one, the maximum width of crack should be, that is WCR should be less than this condition. Okay, then substitute and check, and we get, so WCR should always be less than this one, so it is in the safe condition.